Chapter 20 ended by making culture observable. Instead of asking a regulator to judge what people believe, it asked the supervisor to examine the forensic trace left by behavior under pressure. Whether concerns were raised, whether evidence reached someone with authority, whether the system responded, and whether learning changed the operating pattern before the next incident. That moved culture out of the realm of slogans and into the realm of evidence. Chapter 21 takes the next step. The question is no longer only whether a single organization can demonstrate resilient behavior at a single boundary. The question is what happens when the outcome depends on several organizations at once. Modern services are rarely contained inside a single enterprise. Identity may be provided by one party, payments by another, cloud infrastructure by a third, and case resolution by a fourth. The citizen or customer experiences a single service, even though the institutions supporting it operate under several separate contracts and control environments. That difference matters because the risk boundary has moved beyond the enterprise boundary. A regulator can examine each participant individually and still miss the failure path created by their interactions. Chapter 21, therefore, asks how supervision changes when resilience is a property of the ecosystem rather than of any one entity. The answer is not to create a larger compliance apparatus. It is to govern the shared boundary, align the evidence that matters there, and make regulation itself capable of learning across organizational lines. This chapter is about governing ecosystems, supply chains, and shared boundaries as living systems. The visual on the opening slide is intentionally simple. Two lines travel together, diverge, cross, and then continue. That is what modern value delivery looks like. Organizations remain legally separate, but the outcomes that matter increasingly travel through relationships among them. Traditional regulation was designed around identifiable entities. The regulator could inspect the bank, the hospital, the agency, or the supplier and ask whether each had the expected controls in place. That model still has value, but it becomes insufficient when the public outcome depends on interactions that no single organization owns end-to-end. A well-controlled participant can still be part of a fragile system if the handoffs, dependencies, escalation paths, or recovery assumptions between parties are weak. Regulation that learns, therefore, changes the unit of attention. It still holds individual entities accountable, but it also examines the shared value stream that connects them. It asks what outcome the ecosystem must protect, where the critical shared boundaries sit, which capabilities must work across those boundaries, what evidence is necessary to understand behavior under stress, and how lessons from one event alter the expectations placed on the whole system. The chapter is not proposing a new super-regulator. It is proposing a different supervisory posture, one that can see the ecosystem as it actually operates. The left side of this slide shows the regulatory illusion. Separate entities, each individually assessed, each carrying a green check. If every organization is compliant, the system appears safe. The right side shows the reality. Value streams cross the boxes. Dependencies overlap. A weakness at one node can propagate through several others before the effect becomes visible to the public. That is why enterprise-level assurance can produce false confidence. The regulator may know that each participant has incident procedures, continuity plans, and control attestations. What it may not know is whether those plans are mutually compatible, whether one party's degraded mode overwhelms another, whether escalation information crosses the contractual boundary quickly enough, or whether recovery sequences have been tested together. The supervisory implication is not that entity accountability disappears. It remains necessary. The implication is that it is no longer sufficient. The unit of risk must include the shared boundary where the service actually depends on coordination among parties. Once we see that, the regulatory question changes from, is each participant controlled? To can the connected system continue to produce the protected outcome when one or more participants degrade? That question sets up the rest of the chapter. The NotPetya example on this slide illustrates the core problem. The significance is not simply that malware moved quickly. It is that a localized event traveled through shared identities, flat networks, and tightly coupled dependencies, producing effects far beyond the organization where the initial compromise occurred. The shockwave followed connectivity. That is the ecosystem lesson. In a highly connected environment, failure paths are often relational. They emerge from shared credentials, common suppliers, synchronized processes, common infrastructure, or dependencies whose interactions were never tested under stress. Each organization can have reasonable internal controls, yet the ecosystem remains vulnerable to a mode of failure that exists only between them. This is why the supervisory question on the slide is so important. At a shared boundary, who is responsible for ensuring the ecosystem can recover, and what evidence proves it? The minimum viable capabilities make that question operational. Assure must be able to test cross-boundary evidence. Execute must support coordinated response under degraded conditions. Change must be able to alter shared patterns when the evidence shows that the current arrangement is unsafe. The regulator is no longer looking only for a missing control. It is looking for whether the connected system can recognize, absorb, and learn from cascading failure. This slide makes the paradigm shift explicit. Entity-centric regulation begins with the individual organization as the primary unit of analysis. Ecosystem-centric regulation begins with the end-to-end value stream and the shared boundaries through which the outcome is produced. That single change alters every other supervisory assumption. Under the old model, risk is treated as though failures are mostly contained and individual controls prevent impact. Under the ecosystem model, the regulator assumes that failures can cascade and therefore asks whether participants can recover together under degraded conditions. Accountability also changes. Contractual responsibility still matters, but the supervisor looks beyond the contract to the party that actually has the authority and capability to prevent or mitigate harm at the critical boundary. Evidence changes as well. Static artifacts describing internal preparedness are no longer enough. Shared dynamic QOQM evidence becomes necessary because the regulator must understand whether the connected system is meeting the outcome that matters. Regulatory action then becomes less one-directional. Instead of issuing static rules and auditing localized compliance, the regulator creates learning loops that test interactions under stress and update expectations when the evidence changes. This is not deregulation. It is a more demanding form of governance because it requires the regulator to understand the system rather than only the entities inside it. This slide follows the citizen experience across 4 organizational domains: the accountable agency, regulated financial partners, cloud and identity infrastructure, and case management vendors. The public experiences one stream. The institutions supporting it experience several organizational boundaries. Those boundaries are where many failures originate. Identity is asserted and accepted at one point. Eligibility decisions occur at another. Money moves somewhere else. Failures are detected and escalated at yet another point. Each handoff creates a place where assumptions can diverge. One party may believe that the other owns the escalation. One system may operate within its own tolerance while causing intolerable delay downstream. A vendor may satisfy a service-level agreement, while the citizen outcome still fails. The supervisory discipline is therefore to map the shared value stream and identify the boundaries at which the protected outcome can be lost. That is different from mapping organizations. It asks where evidence must cross, where authority must be clear, and where participants must coordinate before the public feels the failure. Once those boundaries are visible, regulation can focus on the interactions that actually carry risk rather than simply applying more controls to the largest or most visible participant. GRAA becomes especially useful once the boundary crosses organizations because it provides a common language without requiring every participant to operate identically. Governance, resilience, assurance, and accountability can be applied to the shared outcome, even when the parties retain different internal structures, technologies, and regulatory obligations. Governance means collectively defining the acceptable threshold for the shared outcome, not merely relying on what each contract says in isolation. Resilience becomes a property of how the parties interact under stress, including the possibility that one participant will degrade or fail. Assurance requires sufficient evidence to support joint decisions at critical intersections without requiring every organization to expose all of its internal records. Accountability identifies who genuinely has the authority and capability to act when the shared boundary fails. The point is not to blur legal responsibility. It is to make operational responsibility visible. A contract may assign responsibility in one way, while the real ability to mitigate harm lies elsewhere. GRAA helps the regulator and the participants distinguish between the two. It creates a way to govern the shared outcome without pretending that organizational walls stop risk from moving across them. A common reaction to shared boundary governance is to assume that it requires a new coordinating bureaucracy. This slide argues the opposite. The boundary can be governed through clearly assigned roles and evidence relationships, rather than by creating another permanent institution above the existing ones. The boundary steward is the convener. That role maintains the QOQM branch for the shared boundary and triggers the governance routine when evidence drifts. Evidence producers generate the minimum information necessary to understand the boundary: test results, telemetry, incident findings, decision records, and other agreed-upon evidence. Evidence consumers are the leaders, partners, regulators, or assessors who use that information to prioritize capability changes and confirm whether the boundary is improving. The design principle is deliberately lightweight. Ownership is distributed, but the shared boundary is explicit. Participants do not surrender their internal governance. They agree on the questions, outcomes, measures, and escalation conditions that matter at the points where their systems intersect. That creates a common operating surface without creating a new bureaucracy whose primary output is more paperwork. The shared boundary becomes governable because the relationships among evidence, authority, and decision-making are made visible. This slide shows how the 7 minimum viable capabilities span an ecosystem without centralized ownership. The overlay is common. Responsibility remains distributed. Each capability has a cross-boundary expression, because resilience depends on coordination at the points where the value stream crosses organizational lines. Govern may use joint forums to define the key supervisory questions and encode them in memoranda, contractual arrangements, or regulatory guidance. Assure establishes evidence-sharing arrangements for incidents and near misses. Plan coordinates high-risk periods, thresholds, and escalation paths. Design creates shared resilient patterns such as failover coordination, throttling, and fallback modes. Change evaluates how modifications affect the shared stream before multiple parties are exposed to unintended consequences. Execute provides operational playbooks that allow participants to act together without waiting for slow formal escalation when time matters. Innovate creates safe spaces for joint experiments so that no single party is forced to test a novel approach alone in production. The value of the DVMS overlay here is not standardization for its own sake. It is a common set of capabilities that enables different organizations to coordinate around the same protected outcome while preserving their own operating models. The challenge with ecosystem regulation is scale. If the regulator tries to redesign an entire sector at once, the work becomes too broad to learn from. The thin slice approach solves that problem by choosing a single shared value stream in which the stakes are meaningful and the participants are willing to work together. The first step is to select the boundary. The second is to concentrate the QOQM structure on a manageable set of questions, outcomes, and measures. The third is to run scenarios, using both planned exercises and real incidents when they occur. The fourth is to observe and adapt, changing governance and supervisory expectations based on where the capabilities actually performed or fell short. The phrase thin slice matters because this is not intended to create a permanent pilot environment separated from real operations. The objective is to prove that regulation can function as a learning loop on a bounded problem, then carry what is learned into the wider system. The regulator reduces abstraction by working with a real boundary, real evidence, and real participants. That creates a disciplined way to learn before attempting broader change. Cross-boundary assurance does not require every participant to expose every internal record. In fact, doing that would likely make the system less usable, not more. The challenge is to share enough evidence to support a decision, while preserving the detailed records that properly remain inside each organization. The QOQM branch acts as the filter. Because the questions and outcomes are defined in advance, evidence sharing can focus on what is needed to answer them. Structured summaries can be linked to agreed measures, while internal incident records, investigative detail, or sensitive operational data remain governed by the originating party. This is the difference between evidence sharing and indiscriminate data sharing. The 4 sampling questions on the slide give the regulator a practical examination method. What outcome was at stake? How did each party's capabilities respond? How did culture show itself in behavior and escalation? What changed afterward and how quickly? Those questions reconstruct the learning loop without requiring the regulator to ingest every record. The objective is not visibility for its own sake. There is sufficient evidence to determine whether the shared system behaved as claimed and whether learning altered the next operating cycle. This slide brings the chapter together as a continuous learning system. 4 anchors are connected: a thin slice test at a shared boundary, distributed DVMS capabilities, QOQM sampled evidence, and multi-party governance and policy updates. None is sufficient by itself. The value comes from the loop among them. A shared boundary is tested. The participants' capabilities produce observable behavior. QOQM structures allow the regulator and the parties to sample the evidence that matters. That evidence then informs governance, supervisory expectations, and policy. The updated expectations shape the next test, and the cycle repeats. This is what it means for regulation to learn. Regulation is no longer only a static, one-way audit of entities. It becomes a dynamic, multi-party learning system capable of observing how an ecosystem behaves under stress and changing expectations before the next failure repeats the same pattern. The regulator still sets standards and enforces accountability. The change is that those standards can now be continuously informed by operational evidence from the living system, rather than only by periodic submissions and post-failure reconstruction. The final slide reduces the argument to its simplest form. Most of the risks that matter now travel through shared value streams. If governance and assurance stop at the organizational wall, they will miss the very boundaries where cascading failures originate. Systemic resilience, therefore, does not come from building a larger dashboard atop the ecosystem. A larger dashboard can aggregate more data without improving coordination. Resilience comes from quieter forms of alignment. Shared questions, shared outcomes, agreed-upon measures, compatible capabilities, clear escalation paths, and evidence that can be routed to the people with authority to act. That is the central idea of this chapter. The regulator does not need to own the ecosystem. It needs to govern the conditions under which the ecosystem can learn. When participants can see the same protected outcome, understand their responsibilities at the shared boundary, produce evidence from real operation, and change the system when that evidence shows a weakness, regulation becomes part of the resilience mechanism itself. The result is not more bureaucracy. It is a regulatory system that can learn at the same pace as the system it oversees.